to the CANSAT stream. Unfortunately, I'm alone. I'm Charles, one of the co-leaders of the CANSAT team, but I'm unfortunately alone tonight. So let's just get stuck straight into it. Feel free to ask any questions in the chat, and I'll do my best to answer them. But well, yeah, I'll try my best to answer them, but I'll also be multitasking a wee bit. So I guess I'll quickly run through what the CANSAT competition is before I get stuck into it. It's this competition that I and the rest of the team are taking part in that involves designing and constructing a small can-sized satellite, which will record data around its flight, for example, orientation data, humidity, pressure, temperature, and it will also communicate that back to a base station. The real challenge lies in the secondary mission for the teams, because each team is set the objective to record and conduct telemetry on pressure, temperature, and humidity. But in addition to that, we have to think up our own secondary mission for our CANSAT to achieve. And currently, our CANSAT is based around having two Geiger-Müller tubes in a little compartment, a modular compartment, that will record data on cosmic radiation. So here's the schematic for the electronics I'm going to be putting onto a PCB today. I'll quickly run you through what's actually going on in it. So this is the Chip Pro. If any of you are familiar with a Raspberry Pi, or I guess perhaps an Arduino, this Chip Pro is very similar to that. It's an ARM-based computing chip, essentially, that has the ability to communicate with sensors over I2C and UART, which are two serial communication protocols that a lot of sensors use. We have multiple different sensors that mainly communicate over I2C. For example, this is the this yellow box here is all the stuff for a 9DOF, which is an accelerometer, magnetometer, and gyroscope. So they're the things that do the orientation sensing, similar to that of a phone, but hopefully to a sort of higher specification than a phone accelerometer. This is the BME 680. This is going to do most of the primary mission stuff that's required. So this can sense humidity, it can sense pressure, and it can sense temperature, and also gas quality or air quality through, I think it's through capacitive resistance, or capacitive impedance, sorry. Then there's the, this is the HC12. This is not going to actually be incorporated into our PCB. It's going to just have 5 through holes that will plug the HC12 into. All this is doing is taking the information from the chip and sending it over, I think it's a 468 megahertz radio connection. This is a simple buzzer and MOSFET driver for because we lost the CANSAT last year when we launched it, so hopefully the buzzer will help to mitigate the chance of losing it this year, because it's quite loud. These pins just go out to, we're going to have a camera mounted to the bottom of the CANSAT this year, so hopefully we can get some good footage, perhaps even slow motion and or HD footage from the camera that's going to be bottom mounted. And this is our GPS. This we ran into a few problems with because it natively communicates over I2C. So we're using a small chip called a AT-Tiny that will essentially translate the UART communications into I2C compatible communications, as the UART bus is already in use through the HC12. And finally, there's just a small 5 volt voltage regulator, and that's just because some of our components require 5 volts, where the chip only really runs at 3.3 volts and only outputs 3.3 volts natively. So let's get into the PCB design. So I have some dimensions that I've got to stick to, because this can has to be the size of a can, which is in total 115 millimeters by I think 60 millimeters diameter. So within that can we've got, I believe, 55 by 100 millimeters of space to put the PCB. So I'll quickly measure that out, and then we'll get stuck straight into the PCB design. So what I'm doing here is just setting out the dimensions, and then I can resize this box. This is this dimension box. And then I can get straight into it. So these yellow lines here are called the rat's nest lines, which are essentially just telling me where I need to draw wires to in the end sort of result. So for example, this pin needs to connect to this pin, and I'll when I get round to the wiring side of this, that'll come in quite useful. For knowing where to wire everything up. So a lot of this PCB design is quite, it's almost like a massive, quite complicated jigsaw puzzle. It takes up multiple layers. So it's generally fairly straightforward in concept, but takes quite a while of just fiddling around and making sure things fit, because it is quite a tight fit. So generally you want to, for example, these two capacitors, they're quite big, and they also link together, so you generally want to keep them as a group. And I can quickly, there we go, then I can rat's nest it, and it's showing me that these connections need to be made. So chances are that's going to be quite an easy connection to make. Then there are a lot of small components that just need to fit together like a sort of puzzle. How's my volume doing, by the way? Am I alright with volume? Yeah, Nate, it's a tight fit, but it'll work. It'll work. So I think that's the HC12 that's bugged out a little bit. Yeah, that's. But something that we can do with the HC12 is because it's just 5 little pins. I can actually just put them here, and I may have to edit that so they're actual through-hole pins. But otherwise, I can actually just put components underneath them. Maybe not so much the buzzer because it's quite big, but other things probably. This housing's also a mistake. I didn't mean to put that in. So things like this, that's just a bunch of headers for the camera, and what will happen will be that when we actually get this PCB printed, then I can just plug in each of the wires that come out of the camera. And yeah, things like this is the battery, the place where we actually plug in the battery, which we generally want it to be generally want it to be plugged into the edge of the PCB, so it's easy to put the wires in and out of it. But then other things like all these passive components doesn't really matter. This is a button, so I guess it's probably ideal to put it near the edge as well. Perhaps near, if I move this. I can also put stuff on the bottom of it. It just makes things a bit more confusing to wire up later, so I try to stick to one side. Things like this is I think this is it's either the accelerometer or the gyroscope module, and this is the other one. So things like this you want to keep quite close to the center of the board, so because then it'll be in the center of the can, and specifically with the gyroscope, that's quite important to get proper orientation data out of it. I know I said I'd keep that power button near the edge, but I don't think I will. So this is a power switch for the, well, for the pretty much the entire system power. I think I'll do that, and I'll move the battery header down here as well. So this is the power switch. Sorry, I don't know what. That's not the power switch. That's a big transistor. What setup am I using? What do you mean? As in the software I'm using, or how are we actually printing it? Because so the software I'm using is Eagle. Actually, they gave me a free educational license, which was quite well, quite handy. Then the actual way we're going to get the PCBs printed is we're probably going to outsource the PCB, but I think it gets, I may be wrong, but I think it gets milled from a CNC miller. So what I'm doing here is just maximizing the space efficiency, where I've got blue means it's on the back of the board, and red's on the front of the board. We I don't think we actually really need to worry about the so versus last year's design, where we had rails going right down both sides of the PCB. Things like access to these, this is a micro USB port. Things like access to that were quite difficult, but this year we don't really need to worry about that so much. I'm more than happy to have space down both sides for routing the traces. So that's another big capacitor. I think that's probably for the 5-volt regulator, because I can't think of what else it's for. And these diodes are also definitely for the regulator. So this is the BME 680. This is well, it's a slight improvement from the one we used last year, which was a BME 280. It's just got a couple extra features, like it can sense, as I said, the air quality and something else that I can't remember. Air quality and something. That'll come back to me. So for those of you reading chat, Erin's another member of the CANSAT team. Erin, you're welcome to come on a chat with me if you want. So I don't know if you've noticed, but I keep hitting the rat's nest button every so often, and that just that's this button here, and that just reconfigures all these yellow lines to say the sort of closest connection they can make. For example, the closest other thing that needs to use a 5-volt line is this port here, which actually, thinking about it, may be a slight issue because that's quite close to the edge of the PCB. So I may move everything up a little bit, just to get a bit of extra room. And this device here I'm going to have to quickly edit because it's showing up as a surface mounted component where I need it to be a through-hole component. So, if I can remember the button. And that'll be why. There's a slight error. So I'll probably change that later off stream because it's probably not very exciting to fix an error. I'll just keep going for now. Whoops. So currently all these little tiny little components are just bits and bobs from the different sensors we've got going. I think namely the GPS and the 9DOF sensor we're using, because they're the ones that require most extra components out of the main package. I think I'll put that underneath. And I'll put it down here actually. I'll put this one underneath as well because it's sort of halfway between these two lines, and it's whoops, and it's probably the easiest way to route it. I think this is actually last year we had quite a few LEDs on the CANSAT from various different sensors. I think we've only got 1 or 2 this year. That one there is from the GPS. I think it lights up. Nate, we're making a PCB for, yeah, I'll quickly go over what the CANSAT competition is again. Essentially, the CANSAT competition is where we are a team of students and we've got to design and construct a tiny sort of drinks can sized satellite module. conducts telemetry and transmits various data back to a sort of base station laptop or computer. So our CANSAT's designed to record and transmit humidity, temperature, pressure, gas or air quality, the there's also a camera on it, and I think there's also a GPS on it, and orientation data. Then the secondary mission that we've chosen. So each team gets complete freedom over what their secondary mission is. Our secondary mission we've designed around the CANSAT being modular. So we can take out the old secondary mission and put a new one in quite easily. But the current secondary mission we're working towards is it's got 2 Geiger-Müller tubes in it that are gonna record data on cosmic radiation as the CANSAT travels. So we originally had a different mission that was that involved essentially levitating a magnet that would move around as the CANSAT would vibrate, and we were hoping would cause a bit of EMF in an electromagnet or a tiny little coil, but recently we've been having a lot of troubles with that, so we're kind of putting that on hold and going for this cosmic radiation sensing instead, just as we feel it's a more secure mission to work towards. Alright, I'm gonna get Aaron with me, so I'm not speaking on my own. Alright. Hi, Aaron.
Hi.
So this is Erin. She's one of the other members of our team. She's the main one in charge of the secondary mission. Currently, we don't have the Geiger-Müller tubes. They're still ordered, but we're hoping to have them shortly. The company we ordered them from is, we were having a couple issues with ordering things, so
yeah. So hopefully it arrives soon, but who knows.
So this board is starting to get quite populated, so I'm gonna end up having to put more stuff on the bottom of it. Hopefully not. It's not going to be too overcrowded, because it's going to make routing the traces a bit of a pain. Back to the GM tubes. I think we're going to be quite tight on timing, but to test the GM tube, I've not really considered that, admittedly. I think maybe we could somehow source some radioactive sources, maybe from the school technician, and see if they output the desired or the expected output, I guess.
Yeah, probably just steal stuff from physics. So, since they've not arrived, we can't really test them.
Yeah, we're mainly worried right now about whether they'll arrive in time.
And if they don't, I have no clue what we're going to do.
So these have common ground, so I'll just put them next to each other. I'm gonna reduce the grid. That's quite a good suggestion, actually. Maybe we will do that. Actually, yeah, that is quite a good suggestion. Because then we'll get some idea as to the sort of differences in the radiation levels that we know to expect. Oh, this one's a nightmare. That one connects to... That's clearing up quite nicely, actually. Yeah, so the main sort of, because we've got two GM tubes, the advantage of that, actually Erin can probably
I can try.
yeah.
It's basically with two GM tubes. If both of them detect at exactly, well, not exactly the same time, but at a very, very close time, it will be a cosmic ray. Whereas if it was like a beta particle or something, only one would pick it up, because by the time it's gone through that, it's been blocked, so it wouldn't reach the second one. So that's the hope. There is a problem where if it's like two beta particles hitting both tubes at the same time, it might think, oh, that's a cosmic ray. But we'll just test it, see what happens, hope for the best.
So currently a lot of these parts are quite disorganized and may end up shuffling things around a wee bit. Just trying to see if everything will actually fit properly at the moment. These are the last few components going on it. What do you mean by the time difference, Kavi? No. So that's a good start at least. See if I can spread things out a bit more. There's a big space here that I'm thinking we can maybe try and I'd like these to be as close to the center of the board as possible. Actually, they could maybe move down a bit. So closer to the center of the board they are, the better orientation data we get out of it. Go. I think maybe we can iron out some of this. It's looking not too bad now. I think we're quite close to getting to the routing stage, which is where the real fun happens. So for the actually that's a fair point. We plan to mainly do things over software, but the slight issue with that is that exactly, the chip isn't completely a completely flawless solution, but we're hoping that that we can work around that, because we've not really got much space for any hardware solutions. So I can't actually remember if last year we used or we did much with multi-threading, but we plan to incorporate multi-threading this year. We know if it works by well, the main all this stuff, we will know if it works by if we plug it in and we can get a secure GPS lock. We can get good camera footage out of it. We can control the buzzer. We can sense orientation data and all the temperature and air quality data. The secondary mission, probably just through testing, like we were just discussing earlier, where we'll probably do a variation of pointing radioactive sources at it, and or walking up a hill and seeing if levels maybe slightly increase, hopefully.
Right. Better.
Yeah, otherwise it's a bit of a well, I wouldn't say pointless, but less pointful mission.
Yeah. We'll have 2 failed secondary missions within half a year.
So, width, that's not the right width. I did research the right width a while ago. For most of the traces on these won't have more than a couple milliamps going through them. Whoops. I think it was, yes, I think that one looks about right. I should probably check it. Yeah, that'll probably do. So for example, this one I'll probably end up, I don't know why my mouse is a do not enter sign, but I'll probably end up moving it mainly through the bottom layer, and this PCB will likely end up being a 4-layer PCB just because of how full it is. Last year we had to oh, that'll be why. There we go. Last year we had we were lucky to have two PCBs, so we could nicely organize our components between the 2 PCBs. This year it's one big massive package, so it may be a bit more difficult to route everything up. I think, yeah. So, for example, this is here we go. This is the way we generally trace things up. I can probably take that pad out. Because, whoops. Because these through holes can go through both the back side and the front. Yeah, and that neatens it up a bit. And then I can so it gives me a warning if I'm too close to the edge. I could probably go a bit closer, but I guess it's better safe than sorry. I wonder if it's gonna tell me that's too close. Maybe not. I think maybe we can get away with that. So you slowly get the hang of just, it gets quite, yeah, it's got a bit of a knack to it. But you get the hang of it eventually. For example, components like this look quite close to each other, but obviously this is on the top and this is on the back of the board, so they're not actually interfering with each other at all. And things like these through-hole components you can use as pads to get up to the other surface instead of making ones. ground kind of wants to go everywhere. It's actually a bit easier than I expected. I thought it was going to be a bit trickier to route everything up, but I guess maybe that's just because I've not done the hard bit yet. So yeah, this is where it gets a bit complicated. So these traces need to be a bit smaller, but that's all right because they're not really carrying much, and I can probably put the grids down so it's nice and fine. Things like that you don't really want, but actually I could move this up a little bit. I'll put the grid back up to, let's see, say 0.1. That'll do, I guess. Because the component sizes don't quite match up, unfortunately. I'll finish doing these. I'll finish doing all the mined off stuff before I move back up to the big trace size again. There's a lot of common pins on this one actually. Whoops. So, for some of these parts, there's a chance that they can be simplified. I'll move that. Oops. There's a chance they could be simplified. Like, I don't know if all of these pins actually need to be hooked up, but it's the way that through research seems to work, so I'm just gonna stick with what seems to be the case. Oh, do you see that, Aaron? The location for the European ones in Portugal this year.
If we get there.
Yeah. hopefully.
That's nice.
Okay, so that's, I guess, the first problem we've run into the whole time. Why are they not going vertical? Try finer pitch. There we go. Whoops. I'm gonna quickly rip that one up and put it back down. So this, yeah, this ground needs to go. Not quite enough space for all these pads. Gonna have to move it out further. How we're going to solder the small components. Actually, we've been lucky enough to have been sponsored by the company that sponsored us last year with our PCB assembly, and they will, I think they've got proper pick and place machines that so they can assemble this PCB for us. The I can actually quickly show you the other PCB we've got for the secondary mission. Probably should have showed you earlier. This one is generally quite large components, so we're going to try and hand solder them. Most of them are through a hole, and there are a couple SMD components, but they're all quite big. So hand soldering this shouldn't be an issue, really. So yeah, that's what a finished PCB should look like. There's a big transformer down here because it's this is mainly just a power supply. So yeah, that's what we're aiming for. Right. This. I wonder if that's going to cause me issues. Probably.
I'm not sure if you can see anything, by the way, so
Oh no.
yeah.
I hope that's not been like that for long. There we go. Should be fixed. Yep, there we go. I hope that's not been like that for long.
Yeah, I just went back onto it. That's all.
Yeah.
How long it's been on.
So that actually highlights that we could probably move this closer. Yeah, we'll do that. And then is that right? All these are connected to ground. That doesn't seem right to me. Let me check the schematic. Oh wow. No. What component am I looking at? This one. That doesn't look like ground to me. Oh, maybe it is. Maybe it is. No, it's not ground. That's slightly confusing. are these? 24 to 20. Hmm. That must be the way the schematic works. So, I think the hidden pins on this schematic are supposed to be tied to ground, so it must be the it must be right. I'm just gonna go with it and hope for the best. Yeah, it's slightly worrying how many pins are tied to ground. Realised I've reset the trace width. Here we go. Whoops. That's another issue. I've got to move these out a wee bit. Generally it's nice to have things at 45 degrees. Maybe that's not possible. I'll rip them up and put them back down. There we go. Oops. There we go. Do we have a recovery system? Depends what you mean by recovery system. We are generally looking at I'll fix that later. We're generally looking at relying upon this year we have a buzzer and a GPS, and the GPS also has a dedicated antenna, which is the main improvement we've made over our GPS since last year. Simply just because last year we lost our GPS signal, and we're hoping for that not to be the case this year. So we've put in a dedicated GPS antenna and the buzzer, and we're hoping that will be good enough. I don't know what else really we can do.
You're thinking of LEDs as well?
Oh yeah.
So
I think generally with with LEDs is if you can see LEDs, you can see the bright orange parachute.
That's true. But just hope it's not stuck up a tree.
Yeah. The biggest issue we had the biggest issue we had with last year's one was that we couldn't see it because it landed in some very dense foresty swamp stuff. So we couldn't really we couldn't see it, and we ended up spending ages looking for it, but we couldn't find it. It'd be nice to have that running alongside. So this is when it starts getting a bit messy, and ideally I would have had this line running right alongside this this line, because they're both part of the same serial protocol, but don't think that's possible. So afraid we're just going to have to make do with a bit more of an ugly design.
Is our camera inside or outside the CANSAT?
Our camera is we have a camera that will be pointing downwards, and it's so we've got this sort of inner frame, and then we have an outer shell which is a bit bigger, so the camera is isolated from the rest of the CANSAT, but it's still technically inside the CANSAT. It's essentially if you think about like two walls with insulation in between, the camera is the insulation.
Yeah, but it can see outside the CANSAT, right?
Yeah, so it's looking outside the CANSAT.
So then, yeah, that is a point. It would help recovery too.
Yep.
I didn't actually think of that one.
Yeah, I didn't think of that one either. I don't really care about blocking off these pins because I don't think we're actually using them. So this is the first big puzzle we've come across, really. Something that a 4-layer PCB could help, but yeah, I think that's what I'll do. I'll move this component to the right a little bit. Move that. I'll rip that all up. I do that, then hopefully I can wire this up a bit better. Now I've got to get past oh, perfect. Not perfect. Aha. Just enough space for one there. Actually, these can just go straight through like that. So, oh, we've got quite a lot more to do still. So this one goes down here. Needs a finer pitch. I should probably put this closer to the rest of the stuff it needs. I'll put it on this side as well. So in case you were wondering, this is a big coin battery cell holder that we put on last year's module as well, but we didn't actually end up using it. I thought I'd include it into this year's design just in case we need it. So it's just there. And I'll let that one go for a second. I'll move this one closer as well. So these are just two pull down resistors, oh no, sorry, pull up resistors, which means that if no signal's coming through this BME, then it just floats at one of the logic levels. Oh, I just noticed a mistake. Have to fix that. I'll just rip this one up for now. trace size. Oops. That's probably going to cause me issues in a minute, but I'll roll with it for now. I'll do these ones to satisfy. They line up perfectly.
Which PCB is this, Charles?
So this is the PCB for the main CANSAT. So we've got the power supply for the secondary mission, which is on a separate PCB that we've already sent off to get fabricated, and then this one's the main one, so it's got the chip on it and all our sensors on it.
Oh, okay, that makes sense.
Whoops. So I'm mainly trying to figure out these traces, because I feel like they're going to be the most annoying. Primarily just because of the space around the sides. So this one, while I do this, so we can't use any of the space in here because we're probably going to cut it out, just to let the chip lie more flush against the PCB. I don't think it's a required step, but it seemed quite helpful last year to do so.
Okay.
Try going this way. Oh. I was wondering why it was giving me that line. There's a blue one just there. typical, this one has to go all the way up to the top of the board. I think it'll be worth it. My other option would have been to move this one further down, but I think I'd I'd run into some crowding issues down at the bottom of the board. I think everything needs to be quite close to the chip, really. So it's coming together nicely, actually. I think I've maybe done 2/3, 3/4 of it.
Is your plan to finish the whole thing tonight?
Hopefully, yeah. I may not stream all of it. I just thought I'd stream the bulk of it, just because well, it can. I find it can be quite a satisfying process to watch, and it's a good opportunity to answer some questions.
It is satisfying to watch, I just don't really know what's going on.
It's mainly just a massive jigsaw puzzle. Aha. Go. I think I'm gonna have to break the rules a bit and put this around the edge. We do have some buffer room by about 1 mil, so I may actually increase that our dimensions by 1 millimeter.
You might want to check that with Morgan.
Yeah, she told me 56 by 100, but I thought I'd round it to 55.
Okay.
I think I'm gonna unround it. There we go. Oh, that's much better. There we go. We've done, I think, most of the difficult stuff. Oh, one more. Got one more to do. That's ugly. Yeah, I'll do. Oh, that's another annoying one. In hindsight, I probably should have put the AT Tiny close to the GPS. It's a bit late now. Wonder if I can get away with the... It's just a transmit line, so there shouldn't be high currents through it, so I wonder if I can get away with a smaller trace width. I think I did get away with that. That's another long reach. I think I'll move this closer. Actually, no, I won't. See, I think this is a fair example of a not so amazingly laid out one. So once I've finished routing this one, I'll probably try and make another one and see if it's better. um, and I'll maybe make 2 or 3 of this sort of idea. And then after all that, then I'll make a decision on what's the best one.
You're just making more work for yourself here.
No, maybe. I don't think so. Generally, I think last year I went through about a lot more iterations than I plan to go through this year of PCB design, but in fairness, most of that was because we kept on slightly changing a sort of design specification to accommodate different features that we don't really need to do this year because well, it's just a bit better planned out in advance. But that said, this is an amazingly laid out board, so I probably will end up making another one at least. That's another. Oh, that's not the right button. Yeah, never mind, I'll just leave a pad there. Thanks, Nate. Getting there, getting there. I can ignore these ones right now because I think that's just a mistake. I can put a finer width for this one. getting there. Move this. Made a slight mistake with the trace size of that. But it shouldn't matter. Oh. That's also a mistake here that I need to fix.
Is there any update on the fact that you and Morven might not be able to push the competition, Charles?
So yeah, we're still looking into that. We got emailed saying it definitely won't affect our ability to compete in the UK competition. But he didn't really mention anything further than that. I mean, I'd be
um, I'm fairly happy to just look um, like just at the UK competition um, for now until we know actually if we even are going to Europe.
Yeah. Makes sense. I hope we do.
Yeah, that would be fun to go to Portugal.
Awesome for Portugal.
Oh, um, that's better. That lined up quite well. That's badly routed, but oh well. Actually, yeah, I'll fix it. There we go.
think I'm gonna go now, Charles, if that's alright.
Yeah, that's fine. Right, thanks for coming along.
You're welcome, John.
I'll try. Alright, thanks. Bye. Um, um, the PCB is coming on quite nicely actually. I may actually stick with this design. I'm still fairly torn about it. That squint line's going to annoy me, but I don't think there's anything I can do about it. So yeah, it's at the last sort of hurdle. It's at the point that it's actually even starting to lag up my system. I think that may just be because of the amount of traces it's got to render out. So yeah, apologies if the stream starts to lag or anything. Getting there. I'll fix that in a second. Don't let me forget. to the last few, and no matter what, you've got to start really moving things around. Oh, hello. Wrong button. Yeah, this is starting to get quite difficult. Hmm. Hey, there we go. That's a bit better. I'll rip that up and put it back down.
So at this point it starts getting quite difficult to find where you need to actually still connect. So sometimes I'll show you in a second what I do. So what I do is I select none apart from unrooted, and then it shows me I need to make one here, another here, then a couple big ones here. So I go back to this again. I start making those connections. There was one down here, here it is. Easy one. Whoops. There we go. And this big one that needs to be rooted. Oh, that's going to be a pain. So this is an interesting one. Why isn't that raised in a warning? That's not good. I'm going to quickly just reroute this thing completely. all the way down here. Going to be an annoying one as well. This one's got to go quite far. Try and get it, yeah, get it through the unpopulated bit. Quite good, that's quite lucky. Don't think these ones are a necessary step, but I do it just to keep the system happy. What's this one over here? This is going to be annoying. These ones I don't need to worry about, they're a mistake. And these ones I do need to worry about. I think we're just about there. I think we are there. So the final step that I'll show you. This chip isn't a bit too complicated, no, Emily. This is just about as you could probably get it a wee bit neater, but don't think you can get it much neater than this. So the final step I'll show you before I end the stream is generally what you do as the last step, which is if I can find the button, here it is. You just quickly draw around your, nope, that's not the button. Here we go. You quickly draw around your dimensions. Thank you, Ailey. So you go around the edges, and this just does what's called a copper fill, which just adds in a little ground plane. It's quite nice actually. And you draw around the same edges with the top layer. And then you click Rat's Nest and boom, we have a ground plane. Alright, thanks for tuning in, Kirby. Whoops. And I think that's us done. Yeah. Alright, so I thank you all for tuning in, those that are left. I don't know who's actually left. So yeah, thanks, and maybe I'll stream in the future.
don't have any more in mind, but it may come around if it may come around if I can think of something that's quite streamable. Well, chances are we'll probably stream parts of the CANSAT trip, the trip when we go to York. So stay tuned on our YouTube channel for any future videos. We plan to get a lot more vlogs out than we have been doing. Alright, bye.